I'll give a crack at this specialist maths exam 1 from 2027, a number of interesting questions in this video. Question 1, I need to make a note here. This is no longer relevant to the 2023 to 2027 study design, but I'll still do that. So the question wants me to find an acceleration of the body in meters per squared second. So I'll be using F equals to 10 times A equals to 5I plus 12J. Therefore, the acceleration vector is divided by 10, 0.5I plus 1.2J, okay? And the initial velocity of the body is minus 3J meters per second. Find the velocity of the body at any time t seconds. So we can use this formula, V equals to U plus A times t, which means I'm going to get a minus 3J plus 0.5 Ti plus 1.2 Tj. And then I just collect the like terms. So I'll be getting 0.5 Ti plus 1.2 T minus 3 in the bracket J. Okay? So this is using the constant acceleration formula. Technically speaking, part A is related to mechanics. It's removed in the current study design. And part C is also removed in the study design. But suppose we have a question giving the acceleration vector at some velocity, you are still expected to find, let's say, the velocity and the displacement by integration or suitable formulae like a constant acceleration formulae. Find the momentum of the body in kilograms per meters per second when t equals to 2. So the momentum T equals to 10V, m times V, at a t equals to 2. So I'll replace this one with a 2 here. And that is 10 times, let's say, 2 times 0.5, that's 1I, and then plus 2.4 minus 3J, which is 0.6 minus 0.6. So eventually you get a 10I plus 10 times minus 6 minus 6J. So the answer is kilogram meters per second. Technically speaking, I could say this one is still relevant, not relevant, not relevant. All right, let's move on and take a look at the second one. Second one is very simple integration question. So I'll split the fraction into two parts. One part is 2x divided by x squared plus 1. And let's bring this back again. Plus 1 over x squared plus 1 dx, something along this line. Then the first part will give you log e absolute value, x squared plus 1. But this quantity is positive, so I don't need to put absolute value. The second part is a tangent inverse of x. From 0 to 1, then I just slot in the numbers to get log 2 plus pi over 4. Tangent inverse 1 is pi over 4. Subtracting log e1, subtracting tangent inverse 0. So this is 0, this is 0. Therefore, the answer is very simple, log e2 plus pi over 4. And the problem solved. Yeah, that is a very simple integration question. Question 3 is an interesting one. It's a problem stat question in exam 1 environment. So we are talking about the lifetime of a light globe called Shiny or Shiny. The company claims that the lifetime of these globes is normally distributed with a mean of 200 weeks. So population mean is 200. And it is known that a standard deviation of the lifetime of shiny globes is 10 weeks. So sigma, population standard deviation, is 10. Customers have complained saying shiny globes were lasting less than the claimed 200 weeks. It was decided to investigate the complaints. Random sample of 36 shiny globes were tested, and it was found that the mean lifetime was 195 weeks. So n equals to 36, and x bar equals to 195. Use probability between plus or minus 1.96 equals to 0.95 at a plus or minus 3. is 0.9973 to answer the following questions. Null hypothesis looks like if it's less than the claimed population mean, I would say this is a one-sided test. So the original statement or the null hypothesis is always mu equals to 200, but because the customer has complained the lifetime is less than the claimed value, so I say mu is less than 200. Okay, it's a one-side test, one-tail test. The p-value, we have this formula here. It's equal to the sample mean distribution less than or equal to the collected average, 195, given mu equals to 200. And notice that the standard deviation of x bar is 10 divided by root n, which is root 36. And that is 10 divided by 6, which is 5/3. So to calculate this probability, I need to standardize the statement. Say z is less than 195 minus the mean value, 200, divided by 5/3. Or you could actually draw a diagram to see what actually happens. So this is the distribution of x bar. This is 200, and this is 195. This is like a 3 standard deviation away from the mean, below the mean. So you actually get a probability z is less than -3. Now, if z values are calculated, let's say this is -3, this is 3. In the middle, 200 corresponds to a z value 0. Then in the middle, we have 0.9973, which was provided at the start of the question. So the two sides will be 0.0027, okay? The sum of the two tails, the probability will be 0.027. And on one side is 0.0027 divided by 2. That will give you 0.00135, which is roughly 0.001, correct to 3 decimal places. And because the test is carried at a significant level of 0.01, we can say p-value is 0.00135, but it's less than 1%. Therefore, we have sufficient evidence to reject H0. But to answer the question in the context, I would say the mean lifetime is believed to be less than 200 weeks. Okay, so that's what I will be writing down on the paper. The company decided to produce a new type of light globe called Globe Plus. Find and approximate 95% confidence interval. So I mean, the z-score is 1.96. For the mean lifetime of the new globes, if the random sample of 25 Globe Plus globes is tested and the sample mean is found to be 250 weeks, just be careful now. N is 25. X bar is no longer 195, it's 250. And the standard deviation of the population is 10 weeks. Population standard deviation is still 10. So X bar minus 1.96 times sigma divided by square root n is 250 minus 1.96 times 10 divided by root 25. That is 5. So that will give you 1.96 times 2. So that is 250 minus 1.96 times 2. That is 3.92. And that should give you 246.08. And x bar plus 1.96 times square root sigma divided by root n is 250 plus 3.92 equals to 253.92. Therefore, a 95% confidence interval is 246.08, 253.92, something along this line. Let's write this properly. Okay, so that is pretty much the question 4. And let's have a look at the further questions. Let's move on. Question 4. A shaded region in the diagram below is bounded by the graph of sine x and the x-axis between 0 and pi. Shaded region is rotated about the x-axis to form a solid of revolution. Find the volume Vs of the solid form. So we have Vs equals to pi integral 0 to pi sine squared x dx. Now, to calculate this antiderivative, I actually have various options. I'll show you 2 options. Option 1. Notice that you have a sine squared x equals to half 1 minus cosine 2x. So this is the reduced power formula or half angle formula. Eventually, your V is half pi, 0 to pi. 1 take away cosine 2x dx equals to half pi x minus half sine 2x, 0 to pi. So you get a half pi times pi minus half sine 2 pi. Subtracting a 0 plus a 0, well, sine 0 is 0. And this term is 0 as well. So you get a pi squared divided by 2. That is one option. Another option is still based on this formula. Like if you draw the diagram of sine squared x, you will find y equals to sine squared x equals to half minus half cosine of 2x. So the equilibrium is at half, the mean value, the maximum is 1, and the period is now pi because p is 2 pi divided by 2, that is pi. So that is one period of the graph. And you can look at the symmetry pattern. Say the integral here is actually the area under the curve, a shade in yellow, So area of rectangle is pi, area of this bit equals to half pi. Therefore, Vs equals to pi times the value of the integral. That is pi squared divided by 2. Okay? So that is another way you could calculate this answer. But don't forget you need to multiply this yellow value by pi because that's coming from the volume of revolution integral. Now consider the function y equals to sine kx, where k is a positive real constant. The region bounded by the graph of the function and the x-axis between the first two non-negative x-intercepts. That is from x equals to 0 to x equals to pi on k, because this is a dilation factor of 1 over k from the y-axis, etc. So the new volume V2 is pi integral 0 to pi over k, sine squared k pi, kx dx. To evaluate this integral, instead, I will make a substitution, u equals to kx. So du equals to k times dx, and that's why dx equals to 1 over k du. Next thing is if x equals to 0, your u is still 0. You go x is pi over k, your u is k times pi over k, which is still pi. Therefore, the integral will become pi u equals to 0 to u equals to pi sine square of u times du divided by k. And you can bring out the 1 over k, which means, okay, this is 1 over k. And the rest is just the same value as Vs because it's going to be half pi squared, okay? And that will give you 1 over k times Vs. Make sure your answer is written in terms of Vs, okay? Rather than pi squared divided by 2k, because you need to address the specific of the questions, in my opinion. Question 5. As usual, I will show a couple of different ways. Implicit differentiation, gradient of the curve at a point 2, 1. So firstly, I'm not going to differentiate the relation immediately. Instead, I'm going to write it like e to the power x plus 2y at e to the power 4y squared equals to 2e to the power 4. Then, to differentiate this guy, I'm just writing e to the power x plus 2y, but I have to multiply the e term by the derivative of the exponent or the inner function. So it's 1 plus 2 dy dx. X gives me 1, 2y gives me 2 dy dx. Next thing is still a chain rule. Remember, y is some function, implicit function of x. So I'll get e to the power 4y squared. And then if I differentiate, let's say, 4y squared, I'm differentiating that with respect to x. Next, 2e to the power 4. Remember, this is actually a constant, okay? So you actually get e to the power x plus 2y times 1 plus 2 dy dx. That's still the first term. Plus, well, e to the power 4y squared times 8y. But remember, you have a dy dx. And the right-hand side, differentiate the constant, you get a 0. Without any further manipulations, I will be subbing in 2, 1, okay? 2, 1. So you actually get e to the power 1 plus 1 times 2 plus 2. That's a 4. 1 plus 2 dy dx plus e to the power 4 times, let's say, 8 times dy dx equals to 0. Then you get e to the power 4 plus 2e to the power 4 dy dx plus 8e to the power 4 dy dx equals to 0. So you altogether get a 10e to the power 4 dy dx, and that is equal to minus e to the power 4. And then you just divide everything. Cancel that, and get a minus 1. And the dy dx is simply minus 1 divided by 10, okay? So that is, that is like the standard technique. Or you can just use product rule to differentiate ex times e to the power 2y. Another method is here. I'll let a multivariable function fxy equal to e to the power x times e to the power 2y plus e to the power 4y squared minus 2e to the power 4. This is called a particular contour curve at the z level equal to 0, because that's equated to 0 anyway. What I'm going to do is I'll calculate partial f partial x first. Partial f partial x is treating all the e2y, e to the power 4y, and the constant, just like constants. So you'll be getting, let's say, e to the power x times e to the power 2y plus 0 minus 0. Nothing there. And then I'll calculate partial f partial y. That is, I treat my x terms as constant. So I still have ex, but then the derivative of e2y, now I'm just treating y as a variable, 2 times e2y plus, okay, I have to get e to the power 4y squared times 8y, okay? So how can I bring these two together to get the dy dx? Well, dy dx, there is a handy formula, partial f partial x with a negative divided by partial f partial y. So you get a minus e to the power x times e to the power 2y divided by e to the power x times e to the power 2y plus 8y times e to the power 4y squared. And then I just slot in, let's say, 2, 1. Top will be e to the power 2 times e to the power 2. Bottom will be e to the power 2 times e to the power 2 times 1 plus 8 lots of e to the power 4. So minus e to the power 4 divided by Let me have a look. Oh, actually, I should have a 2 here and a 2 here. So be careful with the manipulations. So the bottom will be 10e to the power 4. That is minus 1 over 10. Okay. Just play with the standard method within the study design of 3-4 specialist math. Well, question 6. Question 6, it's 3 vectors, dependence, linear dependence or independence question. What I'm gonna do is I would say, okay, suppose I'm calculating the 3 by 3 determinant of the 3 vectors. Minus 1, add a 6, negative 3. 2, minus 8, 5, 3, 2, and an absolute value 1 minus p squared. I would like that equal to 0 for dependence, for linear dependence. Okay, so my target is to get a simplified expression for this 3 by 3 determinant. Well, minus 1 times minus 8, 5, 2, absolute 1 minus p squared. Take 6, 2, 3, 5, absolute 1 minus p squared. Negative 3. I have 2 minus 8 here and here. 3 and 2 equals to minus 1 minus 8 absolute 1 minus p squared minus 10. Take away 6, 2 lots of 1 minus p squared minus 15. Take away 3, 4, take away 24, that is plus 24, okay? And that will give you 8 lots of 1 minus p squared absolute value plus 10. Take away 12, absolute 1 minus p squared plus 90. And then minus 3 times. 3 times 28, that is an 84, if I'm not mistaken. Just put an 84 here. So altogether, this is the variable term. I'll get a minus 4 absolute 1 minus p squared. 100 take away 84 plus 16. So let's make this equal to 0. So 1 minus p squared equals to 4. So 1 minus p squared, with absolute value, that's equal to 4. Without absolute value, that's plus or minus 4. So p squared could equal to, let's say, 4 here, and p squared equals to negative 3. This is impossible because p value must be real. Or let's say 1 minus p squared equals to minus 4. Therefore, p squared equals to 5, and p equals to plus or minus root 5. But these two values are for linear dependence. Therefore, the question says independence. We must exclude these two values. For linear independence. Okay. So that's pretty much this question 6. And yep, you can also use let's say MA plus MB equals to C, and get the MN value and then get the 1 minus p squared value, but the procedure will be the same for the rest of the question. All right, linearly independent. Just be careful with the wording. Question 7. The velocity of the particle satisfies the differential equation dx dt equals to x sine t, where x centimeters is its displacement relative to a fixed point O at a time t seconds. Initially, t equals to 0, displacement is 1, x equals to 1. Find an expression for x in terms of t. What I'm trying to do is separating the variables, divide both sides by x, multiply both sides by dt. Okay. If I start with x equals to 1, end with x equals to x, then I will change the variable here. Starting with t equals to 0, end with t, and I'll get a sine w, the w here. So the left-hand side will give you log e of u. Notice that this u is positive, larger than 1 is positive. Therefore, I don't need absolute value. And then it's a minus cosine w, 0 to t. Okay, integrating sine will give you minus cosine. But to avoid any stopping up on the negatives or positive, I will get a cosine w here, but then I will reverse the limit. Okay. So the left-hand side will give you log e of x, subtracting log e1. And the right-hand side will be cosine 0 minus cosine of t. So this will be a 0. Therefore, your log e of x equals to 1, take away cosine t. And x is just e raised to the power of 1 minus cosine t. Okay? So the problem is solved. Alternatively, some of you may recognize the left-hand side is log e of x, or you can retain the absolute value x there and eventually cancel it out. The right-hand side will be minus cosine t at c. So absolute value x will be e to the power c times e to the power minus cosine t. And x will be plus or minus e to the power c times e to the power minus cosine t. Just make this chunk a, okay? Let a equals to plus or minus e to the power c. Then you get x equals to a e minus cosine t. You could say, all right, x of 0 equals to 1. Then it's equal to e to the power 0 times a. Actually, sorry, not e to the power 0. It's e to the power minus 1. Cosine 0 is 1. Then a value is going to be e. So x will be e times e to the power minus cosine t, etc. Okay, that is an equivalent form to the answer I obtained in method 1. Find the maximum displacement of the particle and the times, multiple times, okay? Multiple t values at which this maximum occurs. So look at the structure, x is e to the power u, and u equals to 1 minus cosine t. So if you sketch the graph, 1 minus cosine t, it has an equilibrium position at 1, maximum is 2, and it's 0. So it's going up, maximum, down here, okay? Make sure you recognize this is a flip. This is a flipped cosine graph. So this is 2 pi, this is pi. But actually, this graph is standing for all t greater than equal to 0, okay? This is very important. So the next one is a 3 pi. From pi to 3 pi, we add 2 pi. From 3 pi to the next one, we add 2 pi, and so on, okay? That's why for the u value to be the maximum, then I'm able to get the largest possible value of EU. That's why for x max, t equals to pi, 3 pi, 5 pi, etc., etc. In general, we can write it like 2k plus 1 times pi. But if you want to start with pi here, your k must belong to positive integer union 0, okay? Not just z plus or z. If it's z, then I have possibly the negative values of t. So I can't really take that. Another way you could write, I'll put an or here, t equals to 2m minus 1 pi. And your m value belongs to z plus. That is because when you choose n equals to 1 to start with, you have 2 minus 1 times pi. That's pi. So make sure you're starting with t equals to pi here, okay? And U max equals to 2. Therefore, x max equals to e to the power 2 in centimeters. And this answer is in seconds, okay? So that's the second part of the question. Question 8, a nice complex number question. Solve z squared plus 2z plus 2 equals to 0 for z, where z is a complex number. So I'll push a 1 to the right-hand side and I get a -1. Then just complete the square, I get a z plus 1 equals to -1. Take a square root, you have to recognize this will be plus or minus I. Therefore, z equals to -1 plus or minus I. Okay? Next thing is solve z squared plus 2z squared. 2z abs, this is conjugate, not absolute value, bear with me. Conjugate plus 2 equals to 0. So apparently this one has no conjugate. This one has a conjugate. Therefore, part A is different from part B, okay? To solve this equation, we can use technique, let's say, substitution. Let z equals to x plus iy, and then x plus iy squared. Sub that into the equation, plus 2 lots of x minus iy plus 2 equals to 0. And you get it x squared plus 2xyi minus y squared. I squared is -1 plus 2x minus 2yi plus 2 equals to 0. So there I'll be grouping the real part and imaginary part. Say x squared minus y squared plus 2x plus 2 equals to 0. So this is the real part. And I also have 2xy minus 2y times I equals to 0. And factorizing, I should be able to get a 2yx minus 1 equals to 0. Because this I is not equal to 0. This is my imaginary part. Which one looks easier? I think the factorized version looks easier. So from the factorized version, I should be adding y equals to 0 or x equals to 1, okay? Now, with these two cases, get them into the real part equation. If x equals to 1, you have 1 minus y squared plus 2 plus 2. That's plus 4 equals to 0. So your y squared equals to 5. And then y equals to plus or minus root 5. From that, I can see z equals to 1 plus or minus root 5i. Okay, eventually I'm putting that back to z. If y equals to 0, x squared plus 2x plus 2 equals to 0. And this x is very similar to z squared plus 2z plus 2 equals to 0. It will result in x equals to -1 plus or minus I. Non-real. Because in my setting out, I have an assumption x, y values must be real numbers, okay? If I get a complex x value, it doesn't satisfy my assumption, okay? So this case is not suitable. Therefore, eventually I just get z equals to 1 plus or minus root 5i, okay? And the problem is solved. And then lastly, if you take a look at question 9, it has a multi-part, 8 marks, 6 parts. So R of t is actually an ellipse. So S of t is actually a hyperbola. Secant tangent, that's a hyperbola. Cosine sine, that's a ellipse. Position vectors relative to a fixed point O and of particle A and B, respectively, for t greater than or equal to 0, less than or equal to c. C is a positive real constant. It doesn't specify what c is. Show that the Cartesian equation of the path of the particle A is given by this thing. A particle A, we have x equals to -1 plus 4 cosine t y equals to 2 on root 3 sine t. I'm just isolating cosine t and sine t. Cosine t is x plus 1 divided by 4. Sine t equals to root 3y divided by 2. Okay, we know that cosine squared t plus sine squared t equals to 1. Therefore, x plus 1 squared divided by 4 squared add 3y squared divided by 4 equals to 1. So you have x plus 1 squared divided by 16 plus 3y squared divided by 4 equals to 1. Fair enough. It's a very simple trigonometric rearrangement and substitution to convert parametric form into Cartesian equation. Next thing is show that a Cartesian equation of the path of particle A in the first quadrant. So if it's a first quadrant, you have to recognize, okay, it's something like that. Okay? Only this bit. So you are expecting x greater than 0 and y greater than 0 something. Now, look at this equation. If I multiply a 16 both sides, you could say, all right, it's like that. Let's just do x plus 1 squared plus, if I multiply by 16, that's a 12y squared equals to 16. So 12y squared equals to 16 minus x plus 1 squared. And the y squared equals to 1 over 12, 16 minus x plus 1 squared. Taking the positive square root, quadrant 1, taking the positive square root, I should be able to get y equals to 1 over 2 root 3, 16 minus x plus 1 squared to the power half. And the first number is root 3 divided by 6. The second number, I think if you get a 16 take away x squared, take away 2x, take 1, yeah, that's indeed minus x squared minus 2x plus 15. Okay? I think the important thing is your algebraic rearrangement plus you have to justify why you choose the positive square root. Well, hopefully, I wish the question should have specify any reason, some phrase like that. But anyway, show that the particles A and B will collide. Okay, so to show the particles for any potential collisions, that's particle A and particle B. I'll take a picture of the two equations just for a better reference. Okay, so now if I'm looking at these two equations, the next thing I'm going to do is I'll be equating the x part and the y part, okay? For example, I may say, okay, x component minus 1 plus 4 cosine of t equals to 3 divided by cosine of t, that's 3 secant t, minus 1. So we can cancel out the minus 1. And if I multiply both sides by cosine and divide by 4, I have a cosine square equals to 3 over 4. So cosine of t equals to plus or minus root 3 on 2, okay? But t belongs to actually 0 to c. C is not specified. I can't just assume c is half pi. So let's leave the answer like that. And the y component, I have 2 on root 3 sine t equals to tangent t, which is sine t divided by cosine t. If I just push everything to one side, like 2 on root 3 sine t, take away sine t divided by cosine t equals to 0. Then I'm able to get sine t out 2 on root 3 take away 1 over cosine t equals to 0. So there are two possibilities. Sine t equals to 0 or cosine t equals to root 3 on 2. And this result in a common solution to the first equation. We make a conclusion. Therefore, when cosine of t equals to root 3 on 2, the collision will happen, will occur, okay? So that is quite a bit working. You have to equate the x component or I components and j components, eventually arrive at a same equation, or let's say the same t value, but the question did not specify very clearly the specific value of c, so I just leave it like that. And hence find the coordinates of the point of collision of the two particles here. I have to make an assumption if cosine t equals to root 3 on 2, possibly you could have t equals to pi over 6, or let's say 11 pi on 6. That means correspondingly my sine t is gonna be a half or minus half. This is in Q1, this is in Q4, okay? That will result in, let's say, some different values. For example, r of pi on 6 is going to be minus 1 plus 4 times root 3 on 2 I, no bracket around it, plus 2 on root 3 times half j, and that's giving me minus 1 plus 2 root 3 I plus 1 over root 3 j. So it could occur at 2 root 3 minus 1 comma 1 over root 3 or root 3 over 3. And if you use R11 pi on 6, yes, the x value still be minus 1 plus 2 root 3 I, but then the half will be a minus half instead. So you could get a minus 1 over root 3 j, which means you could have a 2 root 3 minus 1 minus 1 over root 3. Question says the point of a collision. Well, could be the first one or the second one. Anyway, if you look at the assessment report, I think it did mention there is potentially another set, which is the second set. But you don't have to specify both. You just have to specify one of them. Okay, part C1, part C2. Show that, okay, derivative left-hand side equals to the right-hand side. And second part, hence find the area bounded by the graph. Okay, the x-axis and the lines x equals to 1 and x equals to 2 root 3 minus 1. Give your answer in the form a root 3 pi over b. A, b are positive integers. Well, one thing I would like to mention is if you recognize 16 minus x plus 1 squared equals to minus x squared minus 2x plus 15. While you are doing part B, the second part of this question, show that part A2. It might be marginally easier. So let f of x equals to 8 sine inverse of x plus 1 divided by 4 plus half x1 times square root 16 minus x plus 1 squared. And that is, that is a slightly different but equivalent form of the inner function. Then I just need to apply the differentiation. Like the first one is 8 times 1 divided by square root 4 squared minus x plus 1 squared, okay? Next one is a product rule. So I have a half square root 16 minus x plus 1 squared plus x plus 1 divided by 2. Now the derivative of the second part is a square root differentiation. So I have a 2 root 16 minus x plus 1 squared. The top is minus 2x plus 1, okay? Then I'm able to get it 8 divided by root 16 minus x plus 1 squared under the square root plus a half square root 16 minus x plus 1 squared. Cancel the 2 and the 2, you get a minus x plus 1 squared divided by 2 square root of 16 minus x plus 1 squared. And just look at the three terms. Eventually, we want to combine all three terms into one term. Then I will deal with the fractions first. For example, I may want to multiply 2 here and divide by 2 here. Then it's a 16. And that's the same denominator. So you get a 16 minus x plus 1 squared divided by 2 lots of root 16 minus x plus 1 squared. And plus another half square root 16 plus x plus 1 squared. And that is much easier because now the first term just simplifies to half root 16 minus x plus 1 squared. The second term is the same. So half plus half, that's a whole lot of root 16 minus x plus 1 squared. And that's exactly the right-hand side. This bit is the same as root 16 minus x plus 1 squared, okay? So this is actually a linear transformation, very obvious. Hence means you have to use the previous part, find the area bounded by the graph of that times the square root. So in that regards, I need to multiply a root 3 on 6 and a root 3 on 6 here to match them and then integrate. What I'm going to do is I'll set out the antiderivative first. So area equals to 1 to 2 root 3 minus 1. And I'll put a root 3 on 6 square root 16 minus x plus 1 squared dx. Okay, something along this line. Then the result will be A is just take a root 3 on 6 here, set out the square bracket. You have A sine inverse of x plus 1 divided by 4 plus half x plus 1 square root 16 minus x plus 1 squared between 1 and a 2 root 3 minus 1. And I will do a small step here. Let u equals to x plus 1. Then if x equals to 1, u equals to 2. X equals to 2 root 3 minus 1. Your u will be 2 root 3. So eventually I'm saying, okay, this is root 3 on 6, 8 sine inverse of u over 4 plus u over 2 times 16 minus u squared from 2 to 2 root 3. Okay? And the calculation should look slightly easier. And you get a root 3 on 6, 8 sine inverse 2 on 4. 2 root 3 on 4 is root 3 on 2. Plus, let's say 2 root 3 on 2, that's a root 3 times 16 minus 12, that's a 4. Subtracting root 3 on 6, you get an a sine inverse of 2 on 4 is half, plus 2 on 2 is 1, and a 16 minus 4 is 12, root 12. Oh, root 3 times root 4 cancelled root 12. And eventually I can bring out an 8 root 3 on 6. This bit will be pi on 3. This bit will be minus pi on 6. So you get a 4 root 3 divided by 3 times a pi on 6. And that is 4 root 3 pi divided by 18, which gives you 2 root 3 pi on 9. So that is the final answer required in the given form. A equals to 2, B equals to 9, etc., etc. Okay, that is my walkthrough to the 2021 Specialist Maths Exam 1. I'll see you in the near future. Bye.